Welcome back, guys. This is Mr. Doyle, coming to you from Lee Summit right now. This is going to be kind of our first video in our digital learning environment that, we have for the next foreseeable future. Some of this section that we're going to cover here today, we've already talked about in class, but we're just going to go over it. And I'm going to try to use Edpuzzle to make sure that you're paying attention and have actually watched these videos. If you recall where we were before school closed down, we were watching a video that was actually looking at the connection between genetics and evolution. So if you have that worksheet, the link to the video is on that. You should go finish watching it because it finally gets down to what makes humans human compared to apes. So it's actually a really cool video. But what we're going to look at here in the next few days will be what we have left in Unit 9, which was evolution. And we're going to go back over a little bit of this history of evolutionary thought, just talk about some of the people in it, what they said, and then we're going to get into what did Darwin actually think at the end of the section here today. There's some good questions that will come from it. But for the time being, this is how things are going to be, so bear with me. If there's anything you think I could do for you guys to make it easier, better, more interactive, let me know. We're going to all be doing this together, so hang in there with me. Okay, so just kind of going back over some of the stuff that Darwin was doing. Darwin lived 1809 to 1882. He was pretty young. He was, 20 years old? No, how old was he here? 1835. He was a pretty young guy. Let's see, he would have been about, 20, 29. He'd been about 25 years old. He's visiting the Galapagos. Basically, his path is he's coming down over here, follows all of South America, makes a number of stops, comes up this way, lands at the Galapagos out here where he stays a little while before they start heading off towards Asia and on the return trip back to England. But at the Galapagos Islands here, he observed differences in organisms on different islands. Differences between tortoises and finches. Even though they're all located in a very similar spot geographically, the isolation on the islands seems to have done something to them. So he's convinced that these organisms changed over time. And so we had two definitions of evolution before we left: development of new types of organisms from pre-existing organisms. And the second one, which is on the next page, that evolution is also a heritable change in the characteristics of a population from one generation to the next. So this really what this is trying to get at here is that evolution does not happen in the same generation. It does not happen in the same generation. Basically, it's only from one generation to the next that we can see things start to change. And I mentioned this before we left. What is a theory? Well, a theory is a well-supported explanation for some aspect of the natural world that incorporates observations, inferences, and tested hypotheses. And when people point to evolution and say, well, it's just a theory, right? There's no official proof. Well, okay, maybe there's not proof, but this is the best supported argument we have currently. There is nothing out there that has a better explanation, nothing out there that has better observations, tested hypotheses, right? There is nothing out there that has a better explanation for this. So this is currently what we go with. If for some reason in the future we get a better explanation, then we'll go with that. But right now, that's what we're going with, okay? So when someone says it's just a theory, or gravity is just a theory, relativity is just a theory, but we seem to believe those as being pretty true. So don't let that be a persuasive argument for you. Okay, so ideas that were concurrent with Darwin a little bit before his time as well. Mainly that species were permanent and unchanging. If God created the world, he created it perfectly. Nothing should go away, nothing should change. It is exactly as he meant it to be. And that the Earth was only a couple thousand years old. They think that it was roughly about 6,000 years old, not 4.5 billion years old. And that was just done by trying to figure out how old people were in the Bible. And in Darwin's time, evidence starts showing up that seems to be contradictory to that. It actually starts with geology and looking at strata. So those are these layers here in the rock. Each one is called a stratum, but altogether they're called strata. And geologists start looking in these strata, and they notice that the lowest strata are the older layers, right? Because the sediment is settling on top of it. And the strata have different fossils. So if you're looking from, say, like down here to like up here, different organisms appeared and disappeared in that time. So what happened to them? Like, where did they go, right? That question brought in some serious issues with they are permanent and unchanging, right? If these species were permanent, why did some of the stuff from whatever this time period was to this time period was disappear? They didn't have an answer for that at first. Another guy here, George Cuvier, is going to reconstruct some fossils. Species looked very different in the past. They do not look like they do currently. Some organisms must be extinct, and this is not going to be taken very well. That they are gone. They existed, and they no longer exist. That's going to go against the prevailing opinion because, once again, God created the world. Everything's perfect. Nothing should ever go away. But the reason for this is he found sudden changes in organisms in adjacent strata. From one layer to the next layer, all of a sudden, species that were in this layer were gone right here. So what happened to suddenly make all of them disappear all at once? And he came up with this idea of catastrophism, that sudden geologic catastrophes cause the extinction of large groups of organisms. Some sort of major event in the past, asteroid striking Earth, giant volcanic explosion, whatever it might have been, ice age, something is causing the death of a lot of species that were not able to adapt to that change. This next guy here, Charles Lyell, big fan of long words, uniformitarianism. The idea that geologic processes that shaped Earth's surface in the past are still at work today. If you've ever been to the Grand Canyon, at the bottom of the Grand Canyon, there is a river, the Colorado River, that is carving into the landscape. And so Lyell is really the first one to realize that that's been going on for a very long time. Forces like that have been going on for a very, very long time, and it's slowly carving away that canyon. And that stuff in the past is still at work today, but it's happening so slowly that we aren't necessarily able to recognize it. So anyways, this idea is called uniformitarianism. And then my favorite one from a French guy, Jean-Baptiste Lamarck, around a little bit before Darwin's time. Lamarckism was that simple organisms could arise from non-living matter. That was kind of going back to the theory of spontaneous generation, if you remember that one. Simple life forms would inevitably evolve into more complex life forms, and his mechanism for this was the inheritance of acquired characteristics. That whatever a species obtained to it physically while it was alive could potentially be passed on to offspring. Individuals inherited traits their parents developed. So let's say, you lost a limb, it gets cut off, right? You lose a hand, and then you reproduce. There's a chance that your child no longer has a hand. Or you get some sort of scar, you could pass that scar on. Well, we don't seriously consider that today. Why? We know that traits are genetic. It's not something that happens to it in its lifetime, but something that happened at the moment that it was conceived or was created. Those are its genetics that can't change, and those are what get passed on. So even if you lose a hand, your genes for producing a hand don't go away. The other issue here with this is that it really only dealt with traits that disappeared. So, how did suddenly humans have heads versus not having heads if it's really about stuff just disappearing? It didn't really explain that too well. But anyways, Lamarckism, one of my favorite ones. Okay, so all of this takes us back to Darwin and another guy that he knew named Alfred Russel Wallace. So in Darwin in 1858, he presents his findings after traveling the world to the British Royal Society, which is kind of like a science group, science society that likes to promote good ideas. That was their job, was trying to enlighten the world. Darwin, it took him a long time, right? That voyage was in 1835, so we're talking like 25 years after that. And part of the reason was that, there's two reasons that he didn't come out with this immediately. One, he knew it wasn't going to be taken well by the public. They were not going to like to listen to what he had to say. And two, he was kind of very careful about choosing his words. So he wanted to be very deliberate about how he wrote stuff. So it took him a really long time to put this together. In fact, this other guy, Alfred Russel Wallace, who was working with him and kind of exchanging ideas, basically came to Darwin right around this time and said, yo, I've got this idea. What if species change because of their environments over time? And Darwin goes, Wallace is on to my idea. I don't want him to publish this before I do. I better get to work on it. So that's kind of what finally forced Darwin's hand to present this. 1859, he writes On the Origin of Species by Means of Natural Selection, which is probably one of the most important books in the history of biology. Produce evidence that evolution occurs. He's talking about the finches and the tortoises. It also explains the variety of organisms on Earth in terms of natural processes. Okay, so 1859, so we're going on just over 150, almost 160 years ago now. So, what does his book actually say? And this is the important part here. Every species must have descended from a pre-existing species. So we all came from something that came before us. Species must change over time. And his example for this was the 13 finches in the Galapagos. Remember, the Galapagos were 600 miles off the coast of South America. So these things were isolated. They were very isolated from the mainland. And then you had the islands themselves, which were isolated from each other. And so these were allowed to basically just develop specifically for their environment there. So this was his evidence that things are changing over time. These finches didn't look like finches on the mainland, and they didn't even look like finches on the islands that were nearby. So, how does it happen? How does natural selection, how does evolution occur? And he says that that term is natural selection. This is the mechanism for descent with modification. This is how stuff changes. It is selected for naturally. Darwin figures the forces of nature that can cause changes in an organism over time. He's going to come up with a few of them here, which is what we're going to talk about, that actually affect a population over time. But he calls the whole process natural selection. So what are they? There's 4 of them right here that he's going to list that are going to determine the direction a species is going to go. Forces that affect a species. Number 1 is overproduction. So, more offspring are produced than resources can support. Species tend to overmake themselves, and that limits the number of individuals that will survive. That a environment can only support a certain number, so if you overproduce for that, only the ones that are fit for that environment are going to survive. Okay, so the first factor affecting natural selection is species overproduce. Number 2 is genetic variation. Even within a species, traits can be different, right? It's really apparent in humans. Hair color, eye color, height, skin color, all kinds of things, okay, within the same species that can be different. So that's genetic variation. Occasionally, new traits appear in a population due to some sort of mutation. All right, it's not happening in a particular individual in the same generation, but it's getting passed on from generation to generation. Okay, number 3, struggle to survive. Individuals must compete with one another. That's part of this overproduction business. That there's more people than there are resources, so individuals must compete with each other. And the trait that makes an individual successful in its environment is called an adaptation. Okay, it is adapted to the environment. The better adapted something is, the more likely it is to survive. The more likely you are to survive, the more likely you are to reproduce. Okay, and then lastly here on our list, differential reproduction. Organisms with the best adaptations are most likely to survive and reproduce. That's what I was just saying. That's what this all kind of leads to. If a trait is particularly useful, then it will become more frequent in the population. So if you get some mutation that is beneficial, okay, you are more likely to reproduce over time and create more and more of that particular trait, which ends up taking up more and more of the population. And those individuals are the ones that tend to survive until a new mutation comes along or something in the environment changes, which makes all of that useless, which is kind of going back to the catastrophism. So, those are the 4 forces that are affecting a population. These are all occurring naturally. Okay, these are all occurring just normally in nature. So here's just kind of a nice picture summary of that. Overproduction, each species produces more than can survive to maturity. Genetic variation, the individuals of a population may differ in traits, size, color, strength, speed, ability to find food. struggle to survive, the ones that are best adapted are going to be the ones that survive. In differential reproduction, the ones that survive are also most likely the ones to reproduce, and over time that trait can become more frequent in the population. So that's just a nice graphic summarizing all of his points. Okay, explaining Darwin's ideas continued. The environment selects the traits. Okay, so humans, say, in the United States, might have a different environment selecting for traits versus humans in Northern Europe or in Sub-Saharan Africa. There's a lot of different traits depending on the environment. That may increase in population by selecting the parents for each new generation. And this led to the term survival of the fittest, which you may have heard. Fitness here does not mean like the strongest or the biggest. Fittest just means, right, fitness is the measure of an individual's hereditary contribution to the next generation. Okay? So, for instance, thick fur on deer that live in mountains means that those deer are more likely to survive. It's not just about living a long life, but how much you can reproduce. Okay, so this thick fur allows them to live longer, and hopefully means that they can reproduce more, which means their species is going to stick around longer. The more helpful a trait is, the more you reproduce, the more the trait appears in the population, the more that population changes. This is different than acclimatization, okay? Survival of the fitness and the idea of fitness is different than acclimatization. This is changes based on a changing environment in an organism's lifetime. Okay, so an example here of that might be something like, if you were to move somewhere where it was very cold, you might start keeping your hair longer. It'll usually retain better body heat. You might start adapting by, or not adapting, but acclimatizing by covering yourself with thicker fur, something to keep you warm. Okay, this is happening within an organism's lifetime. Okay, it's not like their genes are changing. Whereas this stuff here, we're talking about fitness and survival of the fittest and adaptations happening from one generation to the next. I'll link this video later. For whatever reason, Explain Everything doesn't let me play a video within a video, so I'll link this to you guys later. But it asks a really good question. How can you tell the difference between a new species and new traits? Okay, so if we're talking about these species changing over time, well, at what point does it actually become a new species and not a variation? This is actually, it's a really good question. Variation versus new species. At what point is it actually a new species? And not just the same species, but just with a different trait, right? There are a lot of tall humans, there are a lot of short humans. Are they different species? No. At what point do you say that those, if they kept going in that direction, are they actually a new species versus this is just a variation within what it is to be a human? It's actually a good question, and one that Darwin had to really think about, because this is what people brought to him. So, well, if they're changing over time, how do we know we're actually making a new species and this isn't just some variation of what we already had? So that'll do it for right now in terms of this lesson. I will probably go back in, and hopefully if I do this correctly, we'll have questions going as the video is playing, so that way you have to answer them and make sure we know what we're talking about. If you guys have any ideas on what might make this easier, I'll try to include some cool YouTube videos as well that I find during this. There's lots of good stuff out there. This is just a reminder in case you forget. This is chapter 15 from your textbook, so at some point I'll tell you guys to read the textbook as well. Obviously, I won't be able to check notes in a notebook, so stuff like that will probably be looking a little different, but let me know what we can do to make this better for you guys, and we'll see you next time.